Okay, so welcome to Android webinar from JavaPassion.com. My name is Sang Shin, and today's topic is going to be service, Android service. So, as I said in the chatting screen, we are going to actually do the lab together so that you can actually experience some of the exercises together. Of course, you are going to spend some more time later on your own, but for going through the exercise in the hands-on lab, I'm going to actually ask you to start Eclipse and import applications and try things out along with me. Okay, so a short presentation on service. So we are going to talk about the concept of a service and the service life cycles and permissions and local service and remote service. Let's see, there is a question on okay, so let's see what the question is. Okay. Alright, so what is a service? So service is basically background process that does something, okay, without having any user interface. So when an application needs to run something in the background for a long time without any intervention from the user, or a very rare intervention from the user, a service could be actually a good thing to build and run. And service could be running even when the device is being used for other activities. For example, you could build music playing service and it is running in the background, so you can listen to music while you are actually doing some email on your device. So there are two types of services. One is called local service and the other one is remote service. So as you might have guessed, local service is a service in the same process of the application. So that service is accessible only within that application. On the other hand, a remote service is a service that is being exposed to other applications. Now, in order to make your service accessible or exposed to other applications, you have to create what is called AIDL, Android Service Definition Language. It's like an IDL for CORBA, so it defines service contract between service provider and service user. So when you build remote service through AIDL, that is visible and accessible from other applications. Service and notification. So service is a long-lived component and does not implement its own user interface, right? But there could be some cases the service like to notify a user of some important events. Okay, so typically a service will use notification scheme. It might actually display some status bar notification for some important aspects of the service. Now, typically a user interacts with the service through an activity that has an UI. So from the UI, you can actually start the service. And when the service has some important things to notify to the user, then it will use status bar or maybe toast message. So this slide is a bit of repeat. So what facility service provides? So service, a facility for an application to the system about it wants to be doing in the background. Basically, is going to call start service to start the service in the background. So what it means is that it's asking the system to schedule work for the service until the service is stopped by itself or someone else. And it also provides a scheme or a facility for that service to be exposed to other parts of the application, the same application, or other applications. So there is a concept of bind service. So bind service is establishing a connection to the service as a client so that you can invoke the service. So you can bind to a local service and you can bind remote service. So a bit more detailed information regarding binding to a service. So once a service is up and running, and then the activities in the same application or activities in other applications can bind to the service. Now, when you bind the service, you can also start the service if the service is not already up and running. Okay, so we'll see example of that. Okay, service declaration in the manifest file. So every service needs to be declared in the Android manifest file. Okay, so this is an example. You declare your service, and name of the service is music player service. Okay, so as we talked about, there are three different kinds of components that are running on Android platform. Activity is the most frequently used component, and service is another one, and broadcast receiver is another one. So there are three different kinds of components. So every component that are running on the top of Android platform needs to be declared in the manifest file. So activity needs to be declared, and for the same token, service needs to be declared. Okay, service lifecycle. So in order to start the service, you can call start service. Okay, and of course you have to create intent object to start the service. So what happens is that after start service method is called, the platform will retrieve the service and it will call onCreate method of that service, and then it's going to call onStart command method of the service, passing intent object. Now in order to stop the service, you can call either stop service method or stop self. Okay, modes of service. For started service, there are actually three major methods of operation. Actually, two are most important. One is called start sticky, and the other one is called start not sticky. Usually, it doesn't matter as long as the service is up and running, but it is actually playing a role when the service needs to be killed when there is not enough memory space. So in that case, when the memory is not available, when the memory is low, system will kill the service, and then when memory is available, then it will restart the service. Now if you return start sticky return value on your onStart command method implementation of your service, then then the platform will actually start the service again with a new intent object. Now if you return start not sticky return value in your onStart command method of your service, then the service will not get actually started again. So examples of usage of start not sticky is used for services that should be remaining running while processing any command sent to them. So again, this is actually important when the service gets killed in the low memory situation. So for example, a service may be started every 15 minutes from an alarm to post some network state. If it gets killed while doing its work, it will be best to just let be stopped and get started the next time the alarm fires, meaning even if memory is available, it will not restart the service. In fact, it will just wait for the another invocation of the service from the either same application or another application. So we'll actually take a look at this scheme a bit more detail using Hadoop. Okay, so getting a connection to a service. So a client can actually bind to a service to obtain a connection object to the service. So the way you are going to invoke some methods of the service is first you bind to the service by calling bind service method. And once you call bind service, what what happens is that a callback method of connection object gets called, and it will actually pass you iBinder object, which represent the service. Okay. If you don't understand what I'm talking about, that's perfectly fine. We are going to look into this concept, in detail, looking at the hands-on lab, and then we're going to actually run the applications, and we'll actually get to this aspect in a bit more detail. So what's important is when you bind the service, what you get back is basically a service object, which is the type of iBinder, and that's the one that you are going to call to invoke the service. Okay, so running services user interface. So as I said before, services do not have user interface on its own. However, Android platform has the user interface. This is in fact a system level user interface that actually shows you all the running services. So you are going to in fact going to the settings. And actually, why don't I actually go to here? You can go to your home screen, and and then click the display all the application, and then you can click settings, and you can click applications. And then you can display all the running services of your platform. So this is the one that I'm talking about. If you click this guy, then all the services that are running in your applications, on your platform, are being displayed. So I'm going to explain this information when we are looking at the hands-on lab, but basically it shows how much memory space is actually being used, and how much memory space can be in fact available by killing services when there is not enough memory space. The reason they provide this UI interface is so that you have some control as a user, to some control in terms of killing services, because one of the problems that were discovered in early stages of Android platform is that there could be a lot of services that user is not even aware of, and that actually has an impact on the performance of the platform, because it could actually consume memory space and CPU space and things like that. So once in a while you might in fact actually take a look how many services are being run on your platform, and then clean things up. So that's the reason this UI interface has been provided. Okay, so that's what I'm talking about here. Oops. So so this is the reason why running services user interface is provided by the Android platform, so that you can control the services running on the system, because if there are too many services are running, it might have an impact on the performance of your device. Permissions. You can actually specify some of the permissions for your service. Examples that we have in our sample application do not use any of this, but you can certainly specify the access privilege on your service. And in that case, the calling application, the client has to use this permission element in their manifest file in order to start, stop, and bind to the service. And Android platform also provides a bit more fine-grained control, so the service can actually check calling permissions before executing implementation of that call. Okay, so local service and remote service. So local service example. So local service, as I said before, is a service that is running in the same application. So because the service is running in the same application, invocation of the service is a lot more simplified. So basically, clients of the service can simply cast iBinder they receive from the platform, and then basically invoke the method of the service. Okay, so again, we'll take a look at example of this local service and also remote service in a few minutes. Okay, so remote service is basically you have to use AIDA. Okay, so this is a short presentation, but we are going to spend more time on hands-on lab. Okay, so let's open the hands-on lab documentation. Again, as I said before in the beginning of the presentation, I'm going to run the application for each exercise, and I'm asking you to do the same thing so you get the sense of how things work. So we have 8 exercises. So the first 4 exercises are with a local service, and exercise 5, 6, and 7, 8. So we actually 2 sets of remote service. So exercise 5, we are going to run a server, and then you're going to run another application which is functioning as a client, and then another set of remote service server and remote client. Okay, so let's start with the exercise 1. So this is very simple, a service. This is a music player service. Okay, so when you run the application, so let me run the application, and local service music player. So I'm asking you to do the same thing with me. So just run that application, see how it works. So this is very simple application in which music player is being run as a service. So we are going to start the service so that we can listen to the music, and then we are going to stop the service, and then we are not going to listen to that music. Okay, so I don't know why my system is not running, so let me try one more time. So when it's running, it should actually display 2 buttons, play the service and stop the service. And when you click the start the music player service, then you should listen to the music. Let me see what's going on my system. Oh, I'm having some issues. Service launcher is not available. That's interesting. Why that's the case? Let me see if I'm running other things, whether things are working on my system all right. Were you able to run this service? Okay, so this one works okay. So I'm not sure what's going on with my music service. If it doesn't run, then I'm gonna actually do the cleanup and then rebuild it again. Okay, so it says it's on the front. Looks like I'm having some issues with the other particular service. So let me just clean the project. Service music. So I'm going to rebuild, hopefully, and then that hopefully works better. If it doesn't work, then I'll just move on. Yeah, it should work fine. So I don't know what's going on with my platform on this particular. Okay, it works. Okay, so I had to just rebuild the application. So again, if you click, then you are going to listen to the music. Okay, so and you see a toast message. Music player service started, and happy birthday song. And then if you stop the service, then you stop the service. A very simple service. Okay, so let's take a look at the code. So you declare your service in your Android manifest file, and here we are basically calling start service and passing intent object. So we are basically passing explicit service class. So this is explicit the destination, the explicit invocation of the service, and then second button will stop the service. Okay, so pretty straightforward. And service class has to extend service class. So music player service extends service, and here you have to have on create method and on start command method. So this is the method I was talking about. Typically you are going to return start sticky and then on destroy method. So here you are going to stop the service. Here you are going to start the whatever service you want to invoke, and this one gets called by the platform to indicate the mode of operation. So we want the service to continue running until it is explicitly stopped. So return sticky, meaning even if the service gets killed on low memory situations, the service will get restarted. Okay, so this is the layout resource file. There is nothing unusual. So moving forward. Now, exercise 2 is a local service, and this is start only and notification. So you can start and stop the service, and here we do not have binding support. Okay, so when you run the application, you can start the service. So when you start the service will display notification. Okay, so you can see this notification being displayed. And then the service itself also has a variable called the counter. So every second the counter will get incremented. So here I actually talk about the concept of sticky and not sticky. So these are two popular modes that you are going to use. Okay, so this is the example I talked about. So in this case, if you are returning not sticky, and if the service gets killed on low memory situation, and then the service is not going to get restarted even when the memory is available. If you return yes start sticky, then it will get restarted. Okay, so here the notification, if you pull down, then the extended message will get displayed. And when you go back, so when you click this guy, okay, so yeah, so click this guy, then you're going to see this the screen. Then you can stop the service, and then it will display how much time has passed since the service is up and running. And since the service is stopped, it will basically cancel the notification as well. And when you kill the service, on destroy method of the service gets called, and you can see the logging message. Okay, so let's run that application. So the application is service local service start only. So this guy run as so please run the application on your own platform. Okay. Oh, okay, so it looks like I have to do a lot of cleanup. I just clean the old project. So it's rebuilding my applications. Okay, so I'm going to run it again. So start the service, so you can see notification being displayed, and I can drag this guy down, and then I can click this one, and I go back to this screen. Then I can stop the service, and it display how much time the service has been up and running. And as part of the on destroy method, it also cancel the notification. So that's the reason you don't see anything on the notification status bar. Okay, so let's take a look at the code. So we have a service definition declaration in the manifest file, and this is service launcher activity. So basically, again, we are starting the service and stop the service, and the name of the service is local service. So this is a local service. So again, local service extends the service, and so on create is starting a counter. So this one is here. So we are using a timer object to schedule a certain thing. On every 1 second, we are incrementing. Basically, this method, this task gets performed, and this task is basically incrementing the counter by 1 for each second. And this logic is for notifications. Okay. Alright, so hopefully that is relatively straightforward. Now, display running service screen. This is actually described and demonstrated during the presentation of the slide. Again, when you start the service, okay, start the service, and then you can go to your home screen, or you can actually click menu, and then you can see the settings as well. So click see all your application, and then you can click settings, and then click applications. So you can see all the applications that are running and running the running services. So if you click running services, then you are going to see all the services that are running. So in this case, you're going to see local service that has been started. Okay, now this information here. So you can see others 24 megabytes, and 3 says the device has 24 megabytes of unavailable memory in 3 unkillable processes. So these are processes that are in the foreground, meaning that memory is not something that you can get. And however, this one available 15 megabytes and 34 megabytes in 11, meaning that device has 15 megabytes of completely free memory space, and also 34 megabytes of available memory if it needs more memory space. So this is probably the memory space that are being used by services that could be killed in low memory situation. Okay, and again, you can stop the service. If I want to kill this service, you can actually kill the service. Again, this is one scheme that you can control your services yourself through this UI interface, through the settings. So here I can kill the service if I want to. Okay, then your service is gone. Okay. Exercise 3, local service with its own thread. Now, service, you want to actually, if the service is doing a lot of long-running process, for example, if it is doing a CPU intensive work, or it's actually accessing some service, networking services or web services and things like that. So in that case, you might want to have your own thread that performs those tasks. So here you can create your own thread. Okay. So start thread, and pretty much the same user interface, but when you click start service, the service itself will actually create a new thread, and then new thread will perform some long-running task. So in this example, that long-running process is going to display these smiley faces, and every 5 seconds it will in fact change the face. So it will start with a smiley face, and then in 5 seconds it will change it to a neutral face, and then in 5 seconds it will have crying face. So basically you are using new thread to display notifications that are changing every 5 seconds. So that's an example of long-running process. Okay, so here the service is declared in the manifest file, and this is the again the launcher class, a launcher activity class. So it's again the start the service and the stop the service. So this is not that much different from previous exercises. Now this is the service class. Okay, so it extends the service as we have seen before. However, in this case, it's going to have its own runnable object that gets actually executed as a new thread. So I created here, it created runnable object, which is basically changing the notification face in every 5 seconds. Okay, so it's actually in a loop. It's actually running this run method. Okay, and now it actually created a new thread and then passing runnable object. Okay, so typically the way, and then it's going to start that thread. Okay, so typical way of the creating and starting a thread. Okay, so this is notification. All right, so moving forward. Exercise 4, now we are introducing the concept of binding. Okay, so what is binding? Again, when a service is up and running, now it could be bound by a user of the service. Okay, so when you run start and bind, you're going to see this interface. So actually, let's run that application. So you know the start and bind. Okay, so you can start the service, you can stop the service, you can bind the service and unbind the service. And once you bind the service, then you can call a business method of the service. There are two business methods in this service. One is getting a counter value. Again, the service will increment the counter value every second. So you can get the counter value by calling this guy, and then you can reset the counter value. Now let's try to bind service first. Now when you click the bind service, and if the service has not been started before, then it will start the service and then bind it. Okay, so you can see, you know, the message that the service has been started. Now you can call the counter value. So you know, since I start the service, there are 14. The counter value is 14. If you click one more time, it will be 22 in this case. 6 seconds, 8 seconds passed more. And so basically it's calling get counter value business method of that service. And you can call reset counter value business method, then it's going to reset to 0. Again, you can call this guy, and the counter value is keep increasing from 0. Okay. Now if you unbind the service, then you know you are basically unbind. Then if you try to call it again, it says you have to bind to the service first. Okay, since you are not in the bound state, you cannot call this business logic. Okay, so here again you can bind the service, and then you are going to now call the business method. Okay, And again, you can reset counter service. Now, so again, the difference between this application and the previous application is that, in previous applications, you start the service, but you are not really invoking any business method of the service, right? So that's the reason you didn't have to use a binding scheme. Now, in this application, as a client, you want to invoke some business logic, business method of the service. So that's the reason you need to bind it. Okay, hopefully that clarifies the difference between this application and previous applications. So let's see the code. Okay, so in this example, you can start the service and bind the service. So that's the same thing as calling bind service as a single shot. Okay. Okay, so moving forward, so let's see the code. So this is nothing really different. There is nothing really that much different here. Basically declaring your service, and this is a service launcher. Okay, so this is the local service. This is the local service that you are going to call later on. Okay, so when you bind to a service, this variable will be set. Mbound service variable will be set, and then you can call the business method of the service. Okay. Alright, so basically this one has 6 event handlers for 6 buttons, right? One is start, stop, and bind, unbind, call 1, call 2. So the important method that we are going to take a look at is bind listener, and then this is a business logic listener. Okay, so the start listener is nothing really different. There is nothing that much difference. So basically we start the service, and stop the service, again same thing, stop the service. Now I'm going to explain this code in a second. Okay, now let's take a look at the bind listener. Okay, so this is a bind listener. So when you click this button, bind service, this method, this listener, on-click method of this listener class gets invoked. Okay, so what it does is basically is calling bind service method. Okay, and is passing intent object, which specifies the destination service. Again, this service is within the same application, so we are not dealing with the remote service. Okay, and then we are also passing the context bind auto create, meaning if the service is not up and running, we want that service to be created. Now this is important. The second parameter is service connection object. The service connection object is the one that I just skipped here. So service connection object is basically in this service connection class. So it's actually creating an object, but in this class you provided 2 callback methods. One is called onServiceConnect and onServiceDisconnect. And this onServiceConnect is a callback method that is passing you the service object. As I said before, the service object is in the form of iBinder. Okay, so by passing the service object to you in the callback method, when the bind is invoked, now you have this mbound service variable to be set. Now you can call this mbound service later on for business logic method. So in this business logic method, these are 2 business logic methods for getting a counter value, right? So you're going to call the get counter method of that remote service object, and here you are going to call reset counter method of that remote service object. Okay, I want you to spend a couple minutes to get the sense of how things work here. Again, let me just explain one more time, then I'm going to give you a few minutes for you to digest this. Okay, so again, when you click the bind button, this onClick method gets invoked, and it's basically calling bind service, passing service connection object. The service connection object contains callback method that gets invoked by the system, and that callback method is this. So when the connection to the service is created, meaning it is bound, it will pass you the service object in the form of iBind type. Okay, and that iBind service is basically the service you can call from that point on. Okay, so here mBound service is the one that you're going to use later on for invoking business logic method of that service. Alright, so I'm going to actually spend a couple minutes, and if you have any questions, please ask. Alright, so there is one question here. Yeah, so yes, Evgenia actually sent the message that please upload the webinar. Yes, I'm actually recording it right now, so as soon as it is done, it's going to take about 30 minutes to convert to MP4 file. Then I'm going to post it to class website. Okay. Any other questions? Okay, so we have about 20 minutes, so I'm gonna just move ahead, and so I want you to understand the concept of service connection object. So this is the object you pass when you bind, and basically this service connection object contains this callback method, onService callback method, which gets invoked by the system. And the role of this callback method is basically the system will pass you the service object in the form of iBinder. Okay, and then you can call the service object. So you can take a look at the Java documentation. And again, bind service method, I want you to spend some time learning about the bind service, and basically I actually explain it. Okay, so this is the local service class. Again, it's not that much different from the way it gets created, so it extends the service. Now here it does have a two business logic method that are invoked by the client, get counter and reset counter. And so this is basically the logic that actually gets returned is basically returning iBinder object. Okay. So in the client code, in the client code you actually saw the get service method of the binder. So basically that is this code. So yeah, it gets the service, which is the type of iBinder. Local binder is implementation of iBinder interface, and then you call the service object. Okay. Okay, so moving forward, now exercise 5 and 6 work as a combination. So exercise 5 is remote service, server, and exercise 6 is a client. Okay, so it's going to work pretty much the same way as we have seen the local service and client, but in this case, because the service is remote service, client has to be a different application. So that's we are running two different applications. So you're going to run remote service 1 server project. So this is the server project up and running. So remote service is now in place. You can now use a client application, again, start, stop, and bind and unbind and invoke it. It does pretty much the same thing we have seen in the local previous case, but now it is structured in a way that service and client two different applications. Okay, so let's actually run this application first, and then see how things work. So you are going to start the server first, and then you're going to start the client. So run this server application first. Okay, so server is up and running, right? Now we are going to run client. Client, run the client. Okay, so we now can start the remote service, and then we can bind the remote service, and then we can invoke. So you can see we're actually getting the counter value of remote service. So it's returning a counter value. So if you keep invoking, then you can see the counter value gets updated. So the service, again, it will increment this counter every second. So as a client, I can start and bind, and then I can invoke the service. So we have only one business logic method, invoke the getting a counter. And then you can unbind. Then if you try to invoke it, then it will say service not found, meaning you cannot invoke the service because you are not in bound state. So I have to bind it again, and then I can invoke it again. And you can see the counter keep increasing. Okay, so it works pretty much the same as we have seen in the local service and client case, but we are exposing the service as a remote service. Okay, so let's see the code. Okay, so this is here this is a remote service. This is a server application, and we have intent filter, which is set as the remote service. Now, as I said before, because these two applications are in different address space, and they are invoking remote service method, there has to be some marshalling, right? I mean, any kind of communication technology, the parameters and return type need to be marshaled, right? So there is nothing different from that scheme in here. So the way that you are going to make this one work is that you are going to specify, you are going to build what is called AIDL file. So this is like IDL of Cobra. It defines the service interface. So I define the service interface called my remote service, and it has just one single business logic. In fact, it's almost like an RMI, remote method invocation. You define the interface in the form of Java, and that basically is a contract. Once you define it, then Android platform, SDK in this guy, IDE, will generate a skeleton code and the stub code for you. Okay, so as soon as you have this one, you can see the code get generated. So in this case, it will generate I am remote service.java the code. So it's basically creating a skeleton and stub code. So on the server side, it's basically creating the skeleton code. On the client side, it will generate the stub code. Okay, so this is the code that gets generated. Okay. All right, now let's take a look at the activity class. There's nothing really unique about this activity class. It just start the service. Now, the service class is important. So I have remote service, which extends the service. Okay. And here actually using what is called the handler. So I want you to actually understand the concept of handler. You can use handler object to run a runnable task, okay, on the same thread that creates the handler. Okay, so here we are going to create a new task. New task is basically a runnable object. So this runnable object has a run method, basically incrementing the counter, and this task will be run as through the handler. So in on start command method, okay, is going to create a handler, and through the handler you are passing your runnable object. Okay, so basically what it does is that, I'm actually using the same thread that create this handler, and I'm asking that thread to run this runnable task every 1000 millisecond, meaning every second. So every second this run method gets called, and it will just increment the counter. So that's the service. All right, now, so service is relatively straightforward. Now take a look at the client. So this is a client code. So we can start the service, we can then invoke the service, and then it says service is not bound because we haven't bound it yet, right? So you have to bind it first to the service, and then you can invoke the service. Then you're going to see counter value being returned from the server. Actually, client called the business logic method get counter method of the service and gets displayed. Okay, so invoke it again, and then you unbind, and then when you try, then you can stop the service. All right, so let's take a look at the code. So this is manifest file of the client. The client has to have the AIDL as well, so that the stub object for the client gets created. Okay. So this is AIDL. And as soon as you have that AIDL, then this service, my remote service object, gets created, okay, for the client. So it's basically creating my remote service stub object. Okay, so it's actually, you can see the stub here. Okay, so now this is the client code. Okay, so we have a reference to the remote object. Okay, which is a type of my remote service in type. So this is the one that gets created by the platform through the AIDL file. This is something that we have seen in this generate code. Okay. Okay. So the so this is, let's take a look at the so this is the starting the service. Okay. And this is stop the service. Okay. Now this is important code. Okay, so now we are binding to a remote service. So the logic works pretty much the same. Okay, so when you call the bind service, you are passing this service connection object. Okay, so this service connection object is this. So this is a service connection object, and we are going to call it remote service connection object. Again, it has a callback method. So on service connected callback method, which again returns a reference of remote object, remote service object. Okay, so you are going to get remote service object from this bound service. Okay, so you type it as bind service, and then you're going to call this stub object to get a reference of remote service object. So this is representing stub object. It's actually functioning as the proxy for the remote service. And once you got the remote service, then you can invoke the business logic of the remote service. So that is basically this guy. So you're now using that remote service variable to invoke a business logic method of get counter. So you can display the counter through that text view. So you can see the logic is pretty much the same as a local service, except in this case we are using AIDL to generate the stub on the client and skeleton code on the server. And but what's important is that when bind service method is called, you are again passing the service connection object, which contains a callback method, which gets invoked by the platform to pass the remote service object. Okay, again, that is this logic. Is returning, is calling this on service connected callback method of your service, the connection object, and is basically passing you this remote service binder type object, and then you can get the remote service object reference. Okay, so this is basically a stub proxy. Okay. All right, so I'm gonna actually give you, let's say, 2 minutes to look into this code and see whether there are any questions. Actually, let me actually explain exercise 7 and 8 since we got only 5 minutes, and hopefully we'll finish these two exercises before we ran out of time. So this is a bit more involved than exercise 5 and 6, which involved the remote service and then a client, and client just calls the remote service and get the value, so it gets the counter value. Now exercise 7 is a bit more involved in the sense that now the service can actually call the client in return. So you still bind to the service, and then when you bind to this service, you're also passing as a client, you can provide a callback, scheme, callback object, so that service provider can call the client. Okay, so in a sense, now server functions as a client to call the service of the client. Okay, so let me actually explain this application, then you'll see what I'm talking about. So you run the service. Okay, so let me actually run the application first. So I'm gonna run this application, run as. Okay, the service is running. Now I'm going to run the client. Okay. Now you can see I don't have invoked the service. Instead, I have a start the service and bind the service. And then, so let me start the service. So the service is started. I can see the notification here. And then I bind the service. Okay. Now I connect the service. Now what happens is that when I actually bind the service, I also pass a service interface of the client so that the service provider can call me. So basically it's calling me to pass the value of the counter. So instead of calling myself to the service, now the service is calling me in return to pass the counter value so that I can display things. Does that make sense? Okay. So in this case, so let me just explain the code a bit. We have only 2 minutes. So here we have a manifest file, and then so this is the remote interface, register callback and unregister callback. Okay, so this is the AIDF file. Okay, so one of the things that the service provider is for the client to register its own, let's say, service interface called iRemote service callback. So this is going to get invoked by this one, gets invoked by the service provider, in this case to the client. So the client now client is now functioning as a service provider in a sense, okay, in return. So we have actually three AIDL. One is secondary, and the other one is so this is callback, remote service callback. And this is the service provider activity. And so this is remote service. Okay, so basically it's keeping track of client callback the object. So iRemote service callback object. So client will register itself. Okay, so it's going to call itself, it's going to so it's going to register itself, okay, this object. So this object coming from the client, and that will be maintained by the server. So when it is bind, then the service provider will actually invoke the callback object of the client has registered, every second, so to speak, so that all the client who registered for the callback interface object will actually get the message from the server that describe the counter values. Okay, so this is a bit involved, and if it is a bit too much, don't worry about it. As long as you understand exercise 5 and 6, which is a lot simpler, that should be good enough. Okay. All right. So now we have now 6 o'clock. So it's our exit time. Okay. So for exercise 7 and 8 are sort of bonus. So if you have time to look, then take a look at this 7 and 8, which is a bit more complicated than 5 and 6. But as long as you understand 5 and 6, that should be good enough. Okay. All right. Our time is up, so let me just stop.